Okay, as promised, this is the makeup session for Leetcode day 6 grind. So I missed a Leetcode grind day, and this is the makeup for that. This is a series of video where I grind a Leetcode easy problem in 15 minutes. If I can't solve it in 15 minutes, then I'm going to give up and look at the solution. Okay, am I still recording? I am still recording. Let's get started. I'm going to hit shuffle a few times until I get an easy one here. Okay, that is an easy one. Let's do it. So this time is 6:45. I have until 7 to solve this entire thing. If I can't solve it by then, I'm going to look at the solution. So with these Leetcode question, I always find it very helpful to always look at the input and output first before I look at the. My room is very, and my face is way too smooth. I always find it very helpful to look at the input and output and the explanation before I look at the reading part. So let's take a look at the num here. Look like it's inputting an integer num. The output is 14200. Explanation: we do the following: I equal to 0, num at 0, and num at 1 are not equal. So we skip this operation. So it's look like it's doing. So if the number is equal, then it's not doing something. Number 1 and number 2 are equal. We multiply number 1 by 2 and change num2 to 0. Multiply num1 by 2. Okay, num1 and 2 are not equal. Are equal. So they are. We multiply num2. We multiply num at 1 by 2. So that's 2 times 2 is 4. And we change num at 2 to 0. Okay, we're not at 0 yet, but let's continue. The array become 140110. Oh, so this is the res array, and this is the original array. Hang on a minute. No, we are returning the res array. We're not making a new array. So we're doing this in places, it seems like. So now the array is 140110. I equal to 2. Num at 2 and num at 3 are not equal, so we skip this operation. Num at I equal 3 and number 4 are equal. We multiply num at 3 by 2. We multiply num at I, num at 0 and num at 4 are equal. We multiply num at 3 by 2 and change num at 4 to 0. Num at 4 to 0. The array then become 140220. Okay, we multiply num at 3 by 2 are equal. Okay, so I think I get what it's doing now. And in the end, after that, we shift the zeros to the end, and which give the array 1420000. Okay, so I think I can do that. What I'm going to do is that I'm going to do this operation first, and then in the end, I'm going to call another function that shifts all the integer to the front, and then move all the zero to the very end. So I'm not going to make a new array because that is just more challenging, because making a new array is easy. I can just append the result to the new array and then return the new array plus whatever zero amount there is for the length of it. So I'm not going to do that. I'm going to do this in place. The entire thing is going to be in place. Okay, so look like our input is going to be num at 0 and 1, and our output is 1 and 0. Okay, that doesn't really give us a thing. The constraint or number, the length of number is at least 2 and less than 2000. And num at I can be 0 or 1000. So does 0 equal to 0? So input num at 0 and 1. Well, no operation can be applied. So we just shift the number 0 to the end. Okay, so this is fairly simple. I'm gonna do it in place. So what I'm going to do is I'm gonna loop through every single one of these numbers, right? From I 0, 1, 2, 3, and 4. So 0, 1, 2, 3, and 4. So that's except the last one. So from 0 to the last one, from the second to the last one, and then I'm going to check to see if the number before is equal, or the number in front is equal to the number before. If so, then I'm going to I'm going to, if they're equal, then I'm going to multiply it by 2, multiply the current number at I by 2, and then change the number at I plus 1 equal to 0, and then go on. So that's what I'm going to do. So for I in range of length of, this is going to be slow, so I'm going to do length is equal to num, I'm sorry, my ears are really bugging me. Just got to pull it a couple times here. A length of nums, right, minus 1, and then we're going to do length here. So that's what we're going to do. It's going to be from 0, 1, 2, 3, 4 instead of 5. So now we do cur equal to num at I, and next is equal to next val is equal to cur val. Next val, this is just mostly for readability. Num at I plus 1, right? So now we can do if cur val equal to next val, then do this operation, which is nums at, which is cur val equal to cur val. Can I do multiply equal to 2, and then I can do next val equal to 0. Now in the end, we're going to print out num to see what we have, because these are referencing this one. So if we change the value of the reference, we should change the original array. So let's see if we can return just an empty list for now. Let's see what happened. Okay, I knew this. Oh, I always miss something dumb like that, like just nums not found. Nums. Okay, so we have 1, 2. So we're printing out 1, 2, 2, 1, 1, 0. Print out num. Huh. So did we ever gotten here? Okay, so we did gotten here. So I guess I was incorrect on how Python worked. So num at I times 2 is equal to multiply by 2, and nums at I plus 1 is equal to 0. See if that works. Okay, so we are outputting the thing that we want, and now what we're going to do is shift them all over to the very end. So to do that, what we're going to do is going to do for I equal to, for I in range length plus 1 to get to the entire thing. And then what we're going to do is that, actually, you know what? I'm going to use a 2 pointer. I'm going to use 2 pointer. Last index, left pointer, and we are going to have a right pointer. Left pointer, left equal to 0. So that's going to be it. So we're going to do a while loop here, while left. Now left and right pointer. So the left pointer is equal to, the left pointer is where the, so we're going to increment to, right? We're going to find, if the right pointer find a value, it's going to move that value to the left pointer, and then increment the right pointer to keep going, increment the left pointer to keep going. If we can't find a value, like if we can't find an integer other than 0, then we're going to keep increment the right pointer until we find it, and then move it over. So while right is less than length of array, length of num minus 1. I really hope this is not a -1 bug. I mean, if you think about it, I mean, we still need to check the last number. So yeah, let's just do that. We still need to check the last number. So if I do, how do I want to do this? We only want to increment, we always want to increment the right pointer. So if we just do right plus equal to 1 always. So if nums at right is not equal to 0, then we're going to do nums at left equal to nums at right, and right plus equal to, and left plus equal to 1. And we always want to increment the right pointer because the right pointer always moves to the left. Right. So let's see if that works. Oh, I gotta return nums there. Return nums. What? Okay. That's interesting. Why do we got 2 here? Why don't we just print out nums up here just to see what we have? Hmm. 1, 2. Okay, so let's think about this. Left, left, left to here, right? Until we got to here. Nums at left is equal to nums at right. Oh, but we never replaced it. We never replaced. Nums at left is equal to num at right, and num at right. If it's not equal to 0. So why? How come we did it? And num at right equal to 0? Hang on, let's just print out this each time here. Let's do print nums. Run it. Okay. So 142, 142. If the number at right is not equal to 0, then num at left is equal to num at right. Num at left, which is a left pointer, equal to num at right. Do we set the num at right? Oh, okay. So num at left equal to num at right, and num at right is equal to 0. See, that works. So that way we don't have to like have duplicate number. Okay, that didn't work. What is going on? I really want to do this in place. I don't want to do this out of place because that'll be much. 2. Left is equal to num at right. But if we set num at right to equal 0, then it's going to end up being 0 here. Num at left, so which is this number, is equal to num at right. But now we still have this number, which is not supposed to be there. If left pointer and right pointers are not the same, because, okay, so and left not equal to right, then do this. So, because, yeah, that's right. Because when we find it, we want to swap it with a 0. 142. The nums at right and 0, I think. No. Okay. What if instead we look for the first 0? What if instead we look for the first 0, find the number, and then we swap it? Yeah. Is num at right? If num at right is equal to 0, right? We always want to minimize. If num at right is equal to, if num at right 1, 4, not equal to 0, Would we want to swap it? Let's swap it to see what happened. Yeah, let's swap it and see what happened. Right, and nums at right. Yay. Okay, so because we're swapping it, 2 becomes 0. It says here 2 becomes 0, and then it continue. So the first case is 1 equal to 1. Yep, we swap it because we have the same index. Is 1 equal to 4? Yep, that's right. Let's swap it. Equal to 4 is 4. Swap it 4 again. The next one is 0. Nope, that is not the case. Let's go forward one more time. 2 here. Yep, there is a 2. Let's swap it. And then continue and continue. Case 2. Let's see if that works. Okay. That worked. Let's see. 61 millisecond. Let's run that again. I want to see if that was an anomaly. Okay, 56 millisecond. What is the fastest solution? Yeah. For right in range of, okay. Yeah, that's basically the same thing I did. Right equal to right plus 1. Next value. Okay, I saved mine inside of this, so it's more readable, but you can omit that. Yeah, this is an O of n operation. Because we're swapping it. This is the first loop right here, and this is the second loop. So yeah, I solved it just in time. Have a good day. Have a good night. I'm gonna go see a movie. Goodbye.